Let's look at section 2.1, tangent lines and rates of change. We started tangent lines at the beginning of the semester, and then we kind of took a sidetrack on the limits. Now let's go back to tangent lines, okay? Let's suppose I have any old curve here, okay, for some function. Y is equal to f of x. And let's suppose that I end up looking at that point right there on that curve, okay? And that point, let's go ahead and call that, let's say that this is x subscript of 0 on the x-axis, okay? Maybe that's 1, maybe that's 2, maybe that's 3, I don't know, okay? But we're just going to call it some x point in general, x subscript of 1. So this right here would be the point x subscript of 0, and then my function evaluated at x subscript of 0. All right, now let's pick some other points on the curve, okay? Maybe we'll come over here and we'll pick that point right there, okay? Let's go ahead and call that, I don't know, let's call it x subscript of 0 plus h, and f at x subscript of 0 plus h. All right, hold on. How'd you get that? All right, let's see. Let's suppose we start here at x subscript of 0, and then I move h units over to the right here. If I move h units over to the right, that's x subscript of 0 plus h more. X subscript of 0 plus h more right there. So the x coordinate is going to be x subscript of 0 plus h. The second coordinate is going to be my function evaluated at first coordinate, okay? Now let's go back and look at secant lines again, okay? So let's suppose I want to calculate the slope of this secant line that goes through these 2 points right here, okay? M secant. So I'm going to say my slope of my secant line, M, is going to be what? Change in output over change in input. Or maybe you said change in y's over change in x, okay? Either way, it's what? Like this output, f at x naught plus h, minus that output, minus f at x naught, over change in inputs. So these x values, x naught plus h, minus x naught plus h, minus x naught. That's one way we could think of the slope of this line, okay? So up top, I can't really do anything. So that's f at x naught plus h minus f at x naught, because I'd have to calculate these function values before I could go ahead and subtract. But at the bottom, I can subtract these two, and I'm just left with h, right? So what is this right here? This is the slope of your secant line. Now, really what you looked at in pre-calculus as the difference quotient. All right, that gives me the slope of my secant line. What if I wanted the slope of this tangent line right here, okay? Now think of your tangent line at this point right here. It looks something like that, right? So the slope of your tangent line is going to be different by a little bit from the slope of your secant line, like we talked about before in chapter 1. But what happens if instead of calculating the slope of the secant line here, I calculate the slope of the secant line between this point and a point right here? Doesn't that secant line get closer to my tangent line value? What happens if I move real close to that original point? Then what? The secant line and my tangent line, you almost can't tell the difference unless you were to zoom way in. So what are we saying? We're saying that if we take this point and we move it closer and closer and closer to the other point, then what? My secant line gets closer to my tangent line, right? So if I want to find the slope of my tangent line, I could actually do so now, okay? How would I do that? Well, these 2 points, we could call them the same thing. We're just moving closer together. So I can still say it's f at x naught plus h minus f of x naught all over h But now what happens if I move these 2 points closer and closer together? This moves closer and closer together. So what does that mean as far as h? H gets smaller and smaller and smaller. And doesn't that mean this? H approaches 0. So I really want the limit of this function as h approaches 0. And that'll give me m10 now. It's not just an estimate anymore. If I take that limit as h approaches 0, this is my tangent line. Or my tangent line slope, I should say. All right, so let's come up with a definition. Let's come up with a definition, or not come up with one, but let's use the one that they have. All right, your book has this definition. It says, suppose that x naught x subscript to 0 x naught is in the domain of the function f. It is in the domain of, I'm just going to say of f, just to shorten this, of f. The tangent line to the curve. The tangent line, I'm going to abbreviate, tan line to the curve, y is equal to f of x. The tangent line to the curve y is equal to f of x at the point P, where they say it's defined by x subscript to 0, f of x subscript to 0, is the line with equation, y minus f at x naught is equal to m10 times x minus x naught, where m10 is equal to, the limit as h approaches 0 of f at x naught plus h minus f at x naught all over h. Write that a little neater. There we go. Provided the limit exists. All right. I want you to memorize this. Okay? Let's think about this for a second. This part was just a difference quotient that your pre-calculus teacher probably had you memorize, with just a limit thrown in front of it. What is this part? You already know this part. That's really point slope form. Didn't you learn in algebra that point slope form was y minus y naught is equal to m times x minus x naught? Maybe you used ones here instead of zeros, but it really doesn't matter. Notice y naught is f of x naught, m is m tan, x is x, and x naught is x naught. So you really kind of already know that one, or you should know it. If not, memorize it, okay? All right, so what are we saying? We're saying the equation of that actual tangent line is this, and the slope of that tangent line is this part. Now, how are we going to use it? We're going to use it in some examples coming up. Let's see. Our first example. Let me erase all this now. Our first example is going to look something like part A. Find the slope of the tangent line to the curve. Find the slope of the tangent line to the curve. Y is equal to x squared. At the point 2, 4. At the point 2, 4. All right, let's take a look at this. I want to find the slope of the tangent line to the curve at that point 2, 4, okay? What am I really doing? Here's what I'm really doing. Okay, here's a parabola. Looks something like that. Y is equal to x squared. Maybe right here is a point 2, 4, okay? So I'm looking for the slope of this line right here, the tangent line. So it's going to be a positive. Now, if I were to guess, just looking at my horribly drawn picture here, I'd maybe say it's maybe somewhere around +2, +4, the slope of that tangent line. Well, let's actually find it. I did not have to draw this out. I just drew this out so y'all could get a good picture in your head of what's going on, okay? But to actually do this problem, find the slope of the tangent line, I would say M10, according to what we just saw for the definition, is equal to the limit as h approaches 0 of f at x naught plus h minus f at x naught all over h. Now, those of y'all that know the rules for derivatives, don't use them yet, okay? We're going to use this. There's a reason that we go through this long process of using this instead of rules of derivatives. Because whenever you get to Calc 2 or whatever, they're going to start doing proofs with this stuff. So you need to know this backwards and forward. All right, let's see. That's the limit as h approaches 0. What is my function evaluated at x naught plus h? That would be x naught plus h squared. X naught plus h squared, because all you're doing is plugging that in for x. Minus x naught. So let's plug in x naught for x. So you get x naught squared all over h. Well, let's see. I can't really evaluate that at 0 because that'll give you undefined, right? So let's do this. Let's go ahead and expand this out. Let's square this binomial first. So that's the limit as h approaches 0. Now you can write this out times itself and use FOIL if you like. The quick way to do it, square your first term. So you get x naught squared. Multiply these two terms and double them. So if you multiply these two terms, that gives you h x naught. If you double them, that gives you 2h x naught. And then square your last term, plus h squared. That'll be the same thing if you write that out twice and then FOIL it. All right, what do we still have? All this is squared out as this, right? So we still have minus x naught squared all over h. X naught squared, negative x naught squared, 0 out, right? So I have the limit as h approaches 0 of, now in my numerator, I can factor an h out of each one of these terms right here. Now I have h times 2x naught plus h. Remember, I'm just factoring h out of here and here. All over what? H. So what happens to these h's? They divide out. And you have the limit as h approaches 0 of 2x naught plus h. Now evaluate this at 0. So you get 2x naught. Now let's think about this for a second. 2x naught. Have that portion. But they tell me to find the slope of the tangent line to this curve at this particular point. So what they're saying whenever they give you that particular point is they're saying that's x naught and that's f at x naught. So if I want to evaluate this at my particular x naught value, I sub in what from x naught value? 2. So I have 2 times 2 or what? 4. All right, so what did I just find there? Remember we said y is equal to x squared looks like this, right? I just found the slope of the tangent line at that point 2, 4. So I just found the pitch of this line right here, okay? So what did this part give me right here? What this part gave you was that gave you a formula for the slope of all the tangent lines to this curve right here. So it gave me the formula for the slope of the tangent line at that point gave you the formula for the slope of the tangent line at that point, at that point, at that point, at that point, and so forth, okay? So this is just a formula for the slopes of all the tangent lines to this curve, like this one, this one, this one, and so forth. Where this gives you the slope of the tangent line at that particular point, 2, 4. All right, part B. Part B says find the equation of the tangent line. Find the equation of this tangent line. Find the equation of this tangent line. So I just found the slope. Let's find the equation. Find the equation of this tangent line. All right, how did we say we're going to find the equation? We're going to use that point slope form, right? Y minus f of x naught is equal to m tan times x minus x naught. Now, keep in mind from part A, we had the point 2, 4, and we said 2 was the x naught term, and 4 was the f of x naught term. All right. And what did we also say from part A? That the slope of my tangent line, m tan, was what? We calculated m tan to be 4, right? So let's sub in. We have y minus f of x naught. What's f of x naught? 4 is equal to m tan, which we said was what? 4 times x minus, what's x naught? 2. All right, let's simplify this. So y minus 4 is equal to 4x minus 8. And if I go ahead and add 4 to both sides, I get y is equal to 4x minus 4. That's the equation of that tangent line, not just the slope, but the equation of it. How about our next example? Find the slope of the tangent line to the curve. Find the slope of the tangent line to the curve. Y is equal to, or let me go ahead and call it f of x this time just to change things up. Find the slope of the tangent line. Find the slope of the tangent line to the curve. F of x is equal to the square root of x at x naught is equal to 1 and x naught is equal to 9. I'll tell you what, let's do it this way. To the curve that, let's go ahead and call this A, at x naught is equal to 1. So what am I looking for? I'm looking for the slope of the tangent line to this curve. You do not have to do this part. This part right here, just showing you what's going on, the form of concept in your head. Here's the curve, right? Square root of x. This curve has many tangent lines. It has tangent line there, tangent line at that point, tangent line at that point, and so forth. I'm looking for at 1, the next value of 1. What is the slope of this tangent line right there? All right, how do I find that? I say m subscript of tan is equal to the limit as h approaches 0 of f at x naught plus h minus f at x naught all over h. Well, let's see, that's the limit as h approaches 0 at, what does this mean? This means evaluate my function at x naught plus h. So I'm going to put in x naught plus h here. Square root of x naught plus h minus f at x naught. So I have the square root of x naught all over h. Now, if I try to evaluate this, h will go to 0, h will go to 0, so I have 0 over 0 indeterminate. So what do I usually do whenever I have radicals? I usually try to rationalize. So let's try that again. Limit as h approaches 0, the square root of x naught plus h minus the square root of x naught all over h. Multiply by the conjugate at the top, square root of x naught plus h plus the square root of x naught over itself. Square root of x naught plus h plus the square root of x naught. Let's see what that gives us. Let's see, I still have the limit. The limit as h approaches 0. Now, if I multiply this stuff, I get x naught plus h minus x naught at the top, and down below I have h times this stuff. So h times the square root of x naught plus h plus the square root of x naught. Up top, these x naughts are going to zero out. So I have the limit as h approaches 0 of h over h times the square root of x naught plus h plus the square root of x naught. What happens with these h values right here? They divide out, so you left at 1 and you left at 1. So you have the limit as h approaches 0 of 1 over square root of x naught plus h plus the square root of x naught. Now let's try to evaluate it when h is 0. So we have 1 over square root of x naught plus 0 plus the square root of x naught. So that gives me 1 over 2 square roots of x naught, right? 1 over 2 square roots of x naught. Now, what is this that I have so far? What this is right here is a formula when it has x naught in it. So, in other words, that curve, that's a formula for the slope of the tangent line at all places on the curve, okay? We want that particular x naught value to be what? 1 in this case. So we want the slope of the tangent line at that particular value of 1. So that gives me what? 1/2. Right up here, 1/2. Let's look at B. B will want the same thing, but at x naught is equal to 9, or B. So what I just found was what? The slope of the tangent line at this point right here. Now I want it at the point what? 9. How do I do that? I do the same thing. The limit as h approaches 0 and so forth. I already did the part, all the work in part B up to this part right here. So I'm going to say this is the slope of the tangent lines at all points of that curve. I want the particular point now 9. So I'm going to take that 9 and sub it in here. So I have 1 over 2 times the square root of 9. So what does that give me? 1 over 6. 1 over 6. Let's go ahead and throw in, I don't know, part C here, okay? Part C. We can't really throw in part C here, the way I worded this. Oh, well. Let's just throw in an extra example then, okay? What if I tell you to find the equation of the tangent line to y is equal to the square root of x squared. Y is equal to the square root of x at x naught is equal to 9. I want to find the equation of the tangent line at that point. According to what we just did, at x naught is equal to 9 in this curve, where M10 was what? 1/6. All right. If I think about my formula or my equation, my point slope form for finding the equation of tangent line is y minus f at x naught is equal to M10 times x minus x naught, right? Now I need my x naught, which I really have, is 9. That's my x naught value, right? So what's my f of x naught value? Wouldn't that just be my function evaluated at 9? So it'd be like 7 and 9 right here. Square root of 9 is 3. So if they give you the x naught value, the way you find your f of x naught value is you sub that x naught value into your function and calculate. So let's go back to this equation. Y minus f of x naught, which we said was 3, is equal to M10, which we calculated earlier, give 1/6 times x minus x naught. Y minus 3 is equal to 1/6 x minus 9/6 for now, right? So y minus 3 is equal to 1/6 x minus 3/2. And go ahead and add that 3 to both sides. So you get y is equal to 1/6 x minus 3/2 plus 3, right? But what's 3? 3 is what? 6/2. 6/2 plus negative 3/2 is what? 3/2. So y is equal to 1/6 x plus 3/2. There we go. See how I'm doing on time here. I don't want to go over the class period for some reason. I think what we're going to do is maybe that'll be the last part of today's lecture. All right, good luck with the homework.